Hello, I'm Spiros, Magnum PTL. Thanks for coming. So I will do a small introduction of what is Magnum. For you that you don't know, Magnum is an OpenStack API service that creates container clusters. So creates container clusters on VMs or physical machines. In the previous years, we were trying to explain that Magnum offers multi-tenancy in the sense that it offers isolation, but I will try now the opposite way, that offers single tenancy, I would say. So it means that each cluster belongs to one project. So you have isolation that all of your resources are in one project. So it's the strongest possible isolation that we could have in OpenStack. It means that each cluster has its own VMs, its own volumes, and they are not accessible by other projects or other users. All users in one project can have access to all the resources. Magnum focuses on deploying clusters, and we try to add more lifecycle operations than the existing ones, which is create, delete, and scale. We don't have upgrade yet. And we also focus on security deployments for production clusters. So we deploy a set of credentials that you can have one-click deployments like production clusters, like configured for production use cases. We have 4 types of clusters: Kubernetes, Docker Swarm, Mesos, and DCS. I will go to some terminology. We have two main resources in Magnum. One is the cluster template, and the other one is the cluster. So a cluster template, it's basically just an entry in the database that holds all the attributes that describe a cluster. In this case, in this one, you can actually read what it has. So we have some labels that are arbitrary parameters for clusters. And in this one, you can see that we set the Kubernetes version, enable and disabling some types of monitoring. We also have other parameters for the flavor. So the flavors is the size of the VMs or the physical machines. And these are basically Nova flavors that the project has access to. We also specify an image, which is a glance image in this case. And we have the container orchestration engine, which as I said, in our case, is Kubernetes, Docker Swarm, Mesos, or DCS. And other details I would say is network drivers, volume drivers, but these are like cluster type specific. The most important resource is a cluster one. So this is the output, as you can see on the right of if you do show of cluster. Basic details are the API IP of the container orchestration engine, the version of the COE. In this case, it's a Kubernetes cluster, and it has a Kubernetes version of 181. And it also has the node addresses. In this case, it's only a single node cluster, and also the key pair, as I have. So what is a cluster? A cluster in Magnum is a heat stack. We have a design to allow more backends for Magnum, but at the moment, all the implementations that we have are based on heat. Each heat stack has a control plane and a data plane. So in heat terminology, these are resource groups. One resource group is for the master nodes, and one resource group is for the worker nodes. And they can be different, have different flavors, and for now must be to have the same image. It doesn't make any sense anyway to have different glance images like different operating systems. Also, each cluster has a trusty user and a trust. This is one very powerful concept that Magnum has, which means that for each cluster, we have a trust user, which we delegate your capabilities, let's say, to the project, to a trusty user. So this trusty user can use this trust to authenticate with Keystone and create more resources in that project. These resources usually are load balancers in Octavia, so you can have, for example, in Kubernetes, services with type load balancer, or volumes for persistent storage. Docker Swarm and Mesos and DCOS support the Rexray volume driver, and we will think about adding also the Fuxi driver, so you can create volumes that are attached to your containers. And the authentication of this to create these volumes happens with the trust users. This is very powerful in environments that you have like single sign-on, or you have the same credentials for all the services in your organization. And without the trust, you should put your password in plain text in the configuration. So if you are if you share your project with other colleagues, your colleagues could see your password. But in this case, you have a trusted user for this project only. And this is all automated. Also, Magnum creates a CA. The CA can be stored in localhost, but this is only for development. I mean, in the localhost of the API service of Magnum, or in Barbican, or in the Magnum database. So you can have HA. The most secure and, of course, recommended way is to store it in Barbican, which is the specialized service to store CAs. This CA is used to sign the certificates that are used for authentication between the nodes of the cluster, and also for the certificates that the user can use to talk to the cluster. Actually, the simplest way to describe what Magnum does is like the Google Container Engine. So in the Google Container Engine, you create a cluster, in Google Container Engine, only Kubernetes clusters, and you have one master node and many worker nodes, and you get a set of credentials that you talk directly to Kubernetes. You forget about Google Cloud after that, and in our case, you forget about the OpenStack APIs. You talk directly to your cluster. It's the same. It's the exact same concept. Here again, I mentioned the cluster types that we have. One important distinction is Swarm and Swarm mode. So Swarm is the legacy Swarm that used containers in its node that they were having a common etcd, and the state of the cluster was stored there. In Swarm mode, after Docker 1.12, the state of the cluster is stored on the manager nodes, which is transparent to the user. It's, I would say, magic that happens inside the Docker daemon. Clusters also have different we support clusters with different operating systems. Fedora Atomic for Kubernetes and Docker Swarm, CoreOS for Kubernetes only, Ubuntu for Mesos only, and CentOS for DCOS only. We will try to add also CentOS Atomic, which is very similar to Fedora Atomic for Kubernetes and for Docker Swarm. And I would say that if you're trying to use Magnum, try to use Fedora. CoreOS is working, but most of the users use Fedora Atomic. So if you want to share your pain points, you will find more users with Fedora Atomic and Magnum. CoreOS might be popular in other contexts. We also try to support both virtual machines and physical machines. For now, it's only implemented for the Fedora version of Kubernetes, but we will definitely add Swarm mode in this cycle, and probably DCOS, but it doesn't have a lot of traction, so I'm not sure about it. Something is missing from the slide. Sorry. Okay, so clusters can scale up or down, and the hidden line that is missing there is that Magnum also can talk to the API of the COE and push metrics of how many containers you have in your cluster to Ceilometer. This is the missing line. I will quickly describe the features from Pike. The most important ones are the first two. It's Docker Swarm mode support. We use, at the moment, Docker that is embedded in the Fedora Atomic. We haven't added yet CoreOS. And at the moment, the supported version is 13.1, but this will change in Queens that I will describe later, and you can get the latest version. But the most important one was containerized Kubernetes. So we use Kubernetes on system containers, These containers are based on CentOS or Fedora packages. I am the packager for CentOS, and I work very closely with the Fedora packager. So usually, within a few days of release, we have a package, and we can build containers, and you can use it. So this is, I think, very powerful because we use all the infrastructure of Fedora and CentOS. So all the builds are happening public, and you can track them. It's not some containers that you find somewhere and you download. And you can, of course, do your own builds. You can use other means of deploying Kubernetes. You can add your own binaries that you build your own, even for development. Or you can download just the tarbles from GitHub and put them in your containers. CoreOS is using Rocket since a long time, both for the Kubernetes components and both for etcd. But it's not very well supported in Magnum, as I said, due to lack of users. But we would like to support it better, so if you want to try it, you can give it a go, and we can improve it. Something else that we added was, that's a minor feature, but we added persistent storage for etcd. So even if all your VMs are gone, if your worker nodes are gone, I don't know what you can do with them, but if you have it in persistent storage, you can restore it. But we also have persistent storage for etcd. So all the state of the cluster is stored in the persistent volume. So if your backend of Cinder is Ceph, for example, or something else, it's guaranteed that you won't lose your data. We also added monitoring for Kubernetes. We added the official Kubernetes dashboard. Before RBAC, we have only the, let's say, single user dashboard that you can use with kubeproxy for safety. And we added, excuse me, and we also added a Prometheus and Grafana stack. So we run in every node exporter and advisor. We collect data in a Prometheus instance, and we expose them to the dashboard in Grafana. It's a dashboard that we maintain, the Magnum team. We also added Core DNS. Core DNS is an alternative to kubedns. It's only a single binary and a single container instead of kubedns, which is 4. And there is a proposal for Core DNS to be the default DNS for Kubernetes. And one big improvement also that we did for Magnum is we added OpenStack client support, and we're aiming to deprecate completely the Magnum client, the shell client, not the Python SDK, and use only the OpenStack client, so you can get a unified experience with a keyword COE for Container Orchestration Engine. So this is the very ambitious Queen's goals that we have. What we will definitely have is cluster upgrades for Kubernetes and for Docker Swarm. I will talk about in the next slide how this is going to happen. We also try to add cluster node replacement. Instead of trying to fix nodes, we can tell users that with this command you can replace your node. And if you have configured properly your container services, they will just spread again to the capacity of the cluster. We also try to add Kubernetes federation for clusters in different public clouds or private clouds. So initially, we aim to federate Kubernetes clusters within OpenStack clouds and then Google Container Engine. And we have tried also the Oracle Cloud. It should work with Azure, and depending on the bandwidth of the developer that is working on it, we might also add Azure. So how this works is that you have a host cluster, which will be your Magnum cluster, and then you can federate other clusters as it's done with kubelet. So the cluster registers once with a master cluster, and then the host or master cluster talks to the other instances. Exactly how it's happening with Kubernetes, with kubelet and the control plane of Kubernetes. There is also some interest in adding clusters in different availability zones. We will try to add this in this cycle. The change is relatively small. It's about templating the templates with Jinja. And what is also definitely going to happen is adding to run Dockerd in system containers and adding different container runtimes. So again, for Fedora Atomic, this will happen with system containers. So we can add CRIO in a system container, clear containers in a system container, and Docker C again in a system container. So when you create a cluster template, you specify which version that you want and which container runtime that you want, and it will download the appropriate containers, deploy the daemon, and you can use it with initially with Kubernetes. And for Docker Swarm, it will be only Docker. CRI container D might come in the future because it's in beta, and we cannot invest time on that for now. The third to last is the Hit container agent for extra software deployments that you can add. So if you are developing Magnum, or if you have forked, let's say, Magnum on your cloud, you can easily add more software configs, because for now we are limited in 64 kilobytes. But with the Hit container agent, we can add endless software configs and software deployments. The second to last is one very important for production deployments. So what we do at CERN and what other clouds are doing is they patch Magnum to install their certificates in all the nodes. Because to have real certs and to talk to HTTPS, you need to install your CAs in all the nodes. So if you haven't signed, if your CAs are not signed by a public and known certificate authority, and you have your own CA, or if you have self-signed certificates, you need to pass them. So we try to find a way to have some template of software deployments, and then you can specify how to install your certs. So this is aimed for like production and public clouds, I would say. There is also a link for the Queen's blueprints. I will upload and publish the slides so you can browse them, or you can just talk to me on IRC. And I will say now a few words for the most prominent features that we want to add, which is cluster upgrades. So the upgrades will happen in a rolling manner and in 2 steps. One step, it will be to upgrade the control plane, whatever that is, Kubernetes, Docker, Mesos, whatever. And then we will upgrade in batches the worker nodes. For changes that can happen in place, we will try to do it in place to be faster. For example, if you want to upgrade Docker or Kubernetes, which runs in containers, it will happen in place. It will delete the old containers, deploy the new ones. But if you want to install a new operating system, a new kernel, or if your COE is embedded in the node, it will just rebuild the machines. So this is very good for ironic machines, which means you don't have to delete or redeploy. It will just download the new image. It will install it again. There is the spec and review, and there is a prototype implementation that I did for Kubernetes and for the API, so you can go and have a look. And some logistics on how to give feedback. The Magnum channel is the OpenStack containers channel, because it was one of the first containers projects. You can ping me or any other people in the channel. We can also register bugs in Launchpad, and you can use a mailing list using OpenStack Dev and Magnum. Also, the meeting happens on Tuesdays at 1600 UTC. And we try to have it every week. So this week we didn't have because of the summit, but we usually meet every week. And even if it's no one there, I will try to do an update so we can find in the logs what happened to the last week. I think that slide is from the onboarding that I did, but you can find here all the information, or where the documentation is, or where the repos are. So some questions we can do. Have, I think, 2 minutes. So thank you. I will switch to the first slide so you can see the link, so if you want to see the slides. Any questions? Yes.
Any work on scaling masters? So existing cluster, for example, in Kubernetes?
Yes.
More masters, fewer masters?
For Swarm, we will try to add it. For Swarm mode is much easier. For Kubernetes, there is some plumbing to do because at the moment you need to have an HA proxy in front of the APIs. So we don't have a plan currently to scale easily the masters. But it's in the roadmap. So if there is interest, we will try to do it. So it's not a Queen's priority. It's definitely welcome. What is a little easier to do is to scale the master by redeploying it with a new flavor. So if the data are in a volume of etcd, you can scale by rebuilding the master with a bigger flavor. I would like to stress here out that Magnum supports multi-master, but that's immutable and it can change. And the Google Container Engine has only one master. So if they do it with one master, I don't know, sounds sort of a good solution, but their VM is a super HA, I guess, VM that they manage. In our case, I think the best option is to start with a 3-master if you know sort of your use case, and then you can scale with changing the flavor. We will try to add the master scaling, but I cannot say when. Probably after Queens, but we'll see. Any more? Cool. Thank you.